Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we'll be talking about transmission lines as a two-port network. So when we say two-port network, what do we mean? First of all, two-port network. So just look at this. We have a system here, okay, this and this. Now when we say two-port network, we just mean that at this side we have voltage and current, this other side we also have voltage and current. Okay, so here, so we have this current, also current, okay, and then voltage, voltage. Okay, now but the difference is this. This part is the sending end current, sending end voltage, receiving end current, receiving end voltage. Okay, now what the thing is this: the power from the sending end will be greater than the power in the receiving end. They will not be the same due to losses along the way. So in order for what we have in the input to be equal to what we have in the output, we introduce A, B, C, D as constants, ABCD constants. So this ABCD constant, they will just serve as amplifiers to give us the same output as inputs. That is, these guys will help, they will amplify these so that our inputs will be the same as output. So with that, we'll have something like this: voltage at the sending end, that's Vs, equals VR at the receiving end, then IR at the receiving end. Not just like this, but we are going to have these guys, A here, B here. Okay, so it will be A and then B here. Okay, so what should we call this? Equation 1. I think we already have an equation 1, but let's just leave it as equation 1. Okay, so also for our current at the sending end, we'll have it just like this. But let me just write the whole thing again. So for current at the receiving end, at the sending end, it will be VR plus IR, but of course CD, the constants will be there. Okay, yeah, nice, good and fine. So equation 2. All right, now this already looks like that kind of matrix stuff where we say this, where we can simply do this by saying Vs, okay, Vs Is, which is this part, that equals, then we now say, look at this, A, B, C, D. So we pick it like that: A, B, C, D. Okay, and then multiplied by what? We have this VR, so we put it that way, VR, and here we have IR, so we place it that way, IR. Okay, from here you can return back, okay, by saying this multiply this, you have it here, plus this multiply this, you have it here. That's for the first equation, that's for Vs. Then for Is, you come to the second row, saying this multiply this, we give you this, then this multiply this, we give you this. So it's the same thing, we just write it in form of matrix. It's the same thing. Now this ABCD constant, for a short line, it's different from a long line and medium line. So remember, we are still dealing on short lines. So for a short line, remember that we have a formula. Let's put this for a short line. Remember we have, let's use this. Remember we derived, or we got the formula for a short line using this. Vs equals Vr plus Zir. Of course, this is sending end voltage, and from KVL it will equal the receiving end voltage plus any voltage drop along the line. And the voltage drop along this line for a short line is the resistance, resistance and then inductance. Okay, so of course short line has just two parameters. Of course our impedance takes care of that. Okay, our impedance takes care of that. So impedance multiplied by the receiving end current. So this for the short line. So now if you compare this, let's call this equation 3. If you compare this to equation 1, let's look at it. If you compare this to equation 1, what is A? You can see Vs. Okay, AVR. What is the value of A here? We can see that the coefficient A is the coefficient of A is the coefficient of VR here. So what is the coefficient of VR here? 1. Okay, so from that we can see that, let's just put it here, comparing equation 1 and 3. So from that we can see that A equals 1. A equals 1. Okay, A equals 1. Then still on that comparison of equation 1 and 3, what is the coefficient of I here? IR. B. So what is the coefficient of IR here? Z. So that means Z equals, B equals Z. Okay, that looks like 2. Better. All right, so that's for that. Then coming back to equation 2, IS. For a short line, we've said that IS equals IR. Okay, almost like a series network. So for that we have IS equals IR. Okay, for now just call this equation 4. We've given this a number before, but let's just call it equation 4 for the sake of comparison. So comparing equation 2 and 4. Now why are we comparing equation 2 and 4? That's because equation 2 has IS equals this. IS. Equation 4 also has is for IS. So let's compare. So in equation 2 we have VR and the coefficient is C. But in equation 4, we do not have VR at all. Therefore, since we do not have VR, that means C equals nothing, because there is no C is not the coefficient to anything, and VR is not there. So we just say C equals 0. Okay, then next D, or be D. Check, or be D. So the coefficient of D is the coefficient of IR in equation 2. So let's go to equation 4 and look for the coefficient of IR. So in equation 4, the coefficient of IR is 1. So therefore D equals 1. Done. Okay, so this is just the basic idea of this constant, ABCD constant for a short line. Okay, so just bear this in mind that for a short line, a equals 1, b equals z, that's the impedance, then c equals 0 and d equals 1. We are going to need this. I think there are a lot of things we've kept now saying we are going to make use of later, but it's all good. It's all for our good. Okay, so yeah, this is just it for this video for our ABCD constantly from the 2-port network. Okay, so of course leave comment in the comment section, questions, a lot of them. Like, share, subscribe, and thanks a lot for watching. See you in the next video. Bye for now.